So again, one of the most common things I get asked whenever we deal with tension is, what's the formula for tension? The fact is there is no formula for tension. It varies. It depends on what you're doing at the time. So let's just look at this guy. This guy's hanging from the ceiling. Clearly there is a tension in that string that he's hanging from, right? So what we would like to know is, how would I find the tension in that string? Well, when you find the tension in the string, that's the sum of the forces on that object. So you start by doing sum of the forces equals mass times acceleration. So this washer hanging right here, does it have a force of gravity on it?
Yes.
Yeah. So I'm going to draw the free body diagram on this guy. You've got a force of gravity coming down. What's pulling it up?
Tension.
Tension. So the tension is pulling it up. So the way you would do this is you would say tension minus the force of gravity equals mass times acceleration. Notice we've got the force of gravity going down already. So since we've got it going down already, we do not have to account for the fact that the acceleration due to gravity is going down too. So we don't need to plug in negative 10, we can just do mass times 10. All right? So this is the formula for tension in this particular case. If the acceleration is 0, right, this guy is not accelerating right now. If the acceleration is 0, then the tension would be equal to the force of gravity, because this would go to 0, add force of gravity over, tension and force of gravity are equal. If it's not 0, then the tension would be equal to force of gravity plus the mass times the acceleration. All right? Again, this is just a particular case. It's not the only thing that you could do, but it is it's one of the scenarios. Another common scenario with tension is centripetal force. So whenever you have an object that's going in a circle, remember that there is a centripetal force acting in the plane of the circle. So the centripetal force is the net force on that object, right? And the way you found centripetal force was mv squared over r. Okay, so if you want to know the tension in the string, if it's going around horizontally, the only thing holding it in the circle, if it is a object on a string, the only thing holding it in the circle is the tension. So the tension would be equal to the sum of the forces, and it would be the centripetal force. So you could just, like, if this is horizontal, then the tension is the centripetal force. It's the only thing holding it in the circle. On the other hand, if it's a vertical circle, meaning that rather than it going around like on a turn like this, it's going up like this, it's different. Because at the top, you have the tension pulling it down, but then you also have what pulling it down? The force of gravity. So at the top, you have tension plus the force of gravity, because they're both pulling the same direction, equals the centripetal force, or tension equals centripetal force plus the force of gravity. But at the bottom, see, the force of gravity is pulling down and the tension is pulling up. So at the bottom, it's the opposite. It's tension minus the force of gravity equals the centripetal force. So the tension equals the centripetal force plus the force of gravity. And so, I bet this one was supposed to be, at the top it's the force of gravity minus the centripetal force. Or rather, the centripetal force minus the force of gravity. There we go. So the top, tension is the centripetal force minus the force of gravity. At the bottom, centripetal force plus the force of gravity. All right. I've just given you like 3 or 4 different ways to find the tension. These are not by any means the only ways to find the tension. But when you are trying to find the tension, you always need to sum up the forces. The tension will be one of those forces, and you can usually find it. All right? Pause.